Quadrants, rotations, and reflections. Quadrants are really pretty important. You need to know, start top left, go counterclockwise. 1, 2, 3, 4. I don't know why you go counterclockwise, but you do. And one of the things they love to ask is about point values. Remember, in 1, it's going to be plus, plus. And 2, it's going to be minus, plus. 3, it's going to be minus, minus. And in 4, it's going to be plus, minus. So you'll see questions that ask you, in what quadrants will the x and y coordinates, the product of each x and y coordinate of every point be positive or negative? So if it's positive, it would be 1 and 3. Positive times positive is positive. Negative times negative is positive. If it's negative, this and this. When you talk about reflections, there's two kinds. Now we can reflect things across the x-axis. It's like folding them down, right? Or we can reflect them across the y-axis, which is like folding them lengthwise. When we look in a mirror, our reflection is backwards, right? We're being reflected across the y-axis. What changes when you reflect across the y-axis? Well, if this is a point, let's say it's 1, 3. And then this is we'll call it point A, because I'm going to use this little mark here. This denotes that we've reflected it. Well, the x-coordinate doesn't change. Or excuse me, the y-coordinate doesn't change. But the x-coordinate flips sides. So whatever axis I'm flipping over, that coordinate point, so the y in this case, I'm flipping over the y stays the same. The other one will flip sides. Just like it's left and right in a mirror. You don't actually flip vertically, because then if you look in the mirror, you'd be upside down. I'm sure there probably are mirrors like that. So you get the general notion there. X-axis works the same way. Let's say I have point. Let's move this 4 over here a little bit. And put my plus minus back. Let's say I have point B. And let's say B is 2, 1. So B down here, I'm flipping it across the x. So B prime or whatever would be still at 2, but it'd be negative 1. The y values change. I flipped across the x, the y values change. Rotations. Honestly, I feel like the easiest way to do this is to kind of rotate the paper in your brain. When you rotate something, it's really always going to be about the origin as far as we're concerned. But you're spinning it, right? And we're going to cover a practice problem like that in a minute. But if I were to rotate this point 90 degrees, let's say it's 4, 2, or 2, 4, negative 2, 4, sorry. It would end up kind of like over here. And the values would flip around. So you'd end up with like a 4, 2, right? Don't worry so much about the math on that as far as how things flip. You're going to be asked to do shapes when you do rotations, and it's honestly just kind of following it along. Let's take a look at a full screen ACT example for a little more on this. Okay, here's an ACT example. This is a fairly standard one. We're looking for what happens to point A when we rotate around the origin. So again, rotating around the origin, we care about A. And we're rotating 180 degrees, so they don't tell us clockwise or counterclockwise because it doesn't matter. Now, if they do tell you, be careful, make sure you go the right direction. So if I go 360 degrees, I'm going to hit all 4 of these quadrants because A doesn't sit on an axis nor at the origin. So it's that's the easiest way for me to think about it. But I can kind of go like this, 90, right? And I'll be in quadrant 2, be kind of tall and closer to the y-axis. And then I'm going to go down again, and I'm going to end up kind of like over, whoops, I guess I ran out of room there, kind of like over here somewhere. That's really all there is to it. If I go 180 degrees, I'm going diagonally. That's always going to work this way. Now remember my quadrants, this is 1, this is 2, this is 3, this is 4, so I went from quadrant 2 to quadrant 4. Can be determined. That's going to be my answer. Not much to this. And let's look at it one more way. Visually, here's another way you can look at this. Let's actually rotate the question around. By the way, this trick kind of works on paper too if you ever want to try it. So right now, A is in the top left here, right? But if I flip it 90 degrees, A's in the top right. He's now in what would be considered quadrant 1, right? 1, 2, 3, 4. Now if I do it one more time, you'll see that A is in the bottom right. So 1, 2, 3, and A is in quadrant 4. Kind of a cheaty little way to do it, but I've had students do this on paper. It's one of those things, if you can see it, you can see it. If you can't, you can't. But give it a shot, see what happens for you. Okay, that wraps up quadrants, rotations, and reflections. Make sure you spend some time on the graphing function stuff. It's some of the most important stuff in the coordinate geometry section. And good luck.